Okay, let's start with the IVT, the intermediate value theorem. If f of x is continuous on the closed interval a, b, and some value k is in between f of a and f of b, then there exists some value c on the open interval ab such that f of c equals the constant k. F of x is continuous from the value a to b, closed interval, and there exists some value k such that k is in between f of a and f of b. There exists some value c on the open interval a to b such that the f of c equals k.
Ta-da! Now let's try one.
Okay, so for this problem, we first have to start out by testing points. We're going to start out with the f of 0. And the f of 0, when you plug it in, equals -1. And so to test another point, we're going to choose the next integer, 1. When we test that, we get 3. And we know that in between -1 and 3 is 0, so there must be at least one 0 by the IVT on here. And to state that, we must say that f of x is continuous on the closed interval a. Instead of saying a to b, we're going to say 0 to 1. And then as our justification for f of x being continuous, we're going to say as a polynomial. And then we're going to say that the f of 0, okay, the f of 0 is less than 0, which is less than the f of 1. So by the IVT, there exists at least one value c on AB, the open interval, 0 to 1, such that the f of c equals 0.
Now let's start with the EVT. This theorem starts out stating if f is continuous on a closed interval a to b, the function has a maximum and a minimum on the closed interval.
Okay, so on the closed interval from A to B, we say closed because you also have to check endpoints with your graph function f of x, because your endpoint could be your maximum and could be your minimum as shown here.
Okay, now let's get into Rolle's theorem. If f of x is a continuous function on the closed interval a to b and differentiable on the open interval a to b, and f of a equals the f of b, then for some c on the open interval a to b, f prime of c equals 0.
The reason we say that has to be continuous on the closed interval is because if the function is not continuous on the closed interval and we say that these are equal at the same constant, this does not have to equal 0 because this is a line and it is no way related to these 2 points.
Let's move on to the MVT, which states if f of x is continuous on the closed interval a to b and differentiable on the open interval a to b, then there exists some value c on the open interval such that f prime of c equals the f of b minus the f of a all over b minus a. Now here's an example.
So here we're going to start with A. What does the MVT guarantee on 1 to 3 for f of x equals x squared minus 2x plus 3? So first you have to state that it is continuous and differentiable. So you would say f of x is continuous on closed interval 1 to 3 and differentiable on open interval 1 to 3. So by the MVT, there exists some C on 1 to 3, the open interval, such that the f prime of C equals the f of 3 minus the f of 1, all over 3 minus 1. Now make sure you don't write down f of A minus f of B. Make sure you plug in your intervals into the equation. 6 minus 2 over 2, which would equal 4 divided by 2, which equals 2. And then you have your answer. Okay, so you would take the f of x, which equals x squared minus 2x plus 3, and you would find the derivative, f prime of x, which would be 2x minus 2, and then you would plug in c into x, so it would be 2c minus 2, which equals 2, as we found in A. You would add 2, so 2c equals 4, divide by 2, c equals 2.
Now let's move into the fundamental theorems of calculus. The first one states if f of x is continuous on the closed interval a to b, and f of x is the antiderivative of little f of x on the closed interval a to b, then the integral from a to b of f of x dx equals the big F of b minus the big F of a.
Okay, so the first thing we need to do is antiderive this. So for x squared, we bring it up a power, and then put in front the reciprocal. And then for plus 1, we just put in an x. And then this is solved from 0 to 3. So we plug in 3. And then we take this entire thing and minus it by what we when we plug in 0. So plug in 0. And then this comes out as 9 plus 3. And then this comes out as minus 0. And then 9 plus 3 is 12. So your answer is 12 for this integral right here.
Now for the second fundamental theorem of calculus. It would be the derivative of the integral from a to x of f of t dt, which would simply be the f of x. Now when you're using chain rule, you would do the derivative of the integral from a to u of x, that's supposed to be an x, ignore that, of f of t dt, which is the f of u of x times the u prime of x.
Okay, so with this example, you would take this equation and plug in the value on top, which is x squared. So you would have x squared cubed minus 6 x squared all squared plus 5 x squared. And Because it's x squared, you would use the chain rule and multiply it by 2x. And then you would multiply it all out, and it would become 2x to the 7 minus 12x to the 5th plus 10x cubed.
And last but not least, net change. And the integral from a to b of f prime of x dx equals the f of b minus the f of a. Now, when you're only given the function and one value, to find the other value, you use the integral and then use the value given as shown.
There are 3 types of net change problems. The first ones are basic, which give you an initial value, an equation to integrate, and they have you find a value or absolute extrema. Okay, so for this first example, you're given the f of 0 equals 2, and f prime of x is 4x cubed plus 2x plus 3. And you want to find the f of 3. So what you're going to do is you're going to put the f of 3 equals the f of 0, which is your initial value, and then plus the integral from your initial value here, 0, to the one you want to find, which is 3, of 4x cubed plus 2x plus 3 dx. And then you would integrate, so it would be 2 plus, that would be x to the 4th, plus x squared plus 3x from 0 to 3. And then you would plug it in. So it would be 2 plus 3 to the 4th plus 3 squared plus 3 times 3 minus 0 to the 4th plus 0 squared plus 0 times 3, which is simply 0, so we don't have to worry about it. And 3 to the 4th is 81, and then 3 squared is 9 plus 9, all plus 2, so then that would be 1899 plus 2, which is 101. So then you can say the f of 3 is 101.
Okay, so in this problem, we are given that f of x is continuous on 0 to 4, the initial value f of 0 equals 2, and what f prime of x equals. And we're told to find the absolute max of f of x on 0 to 4. So we're going to start out by finding the critical numbers. So to do that, we're going to set f prime of x, which is x squared plus x minus 1 equal to 0. And to do this, we're going to factor. And on the test, never do this. If you're going to do this, always write a when statement when x equals. So we're going to factor here, and then this factors to be x minus 1 and x plus 1. So this is 0 when x equals negative 1 and x equals 1. However, since our interval is from 0 to 4, this one does not apply here. And we're going to find the value at x equals 1. So we know, we're going to do Canada's test. So we know that the f of 0 equals 2, but we need to find the f of 1. And so we do the f of 1 equals the f of 0 plus the integral from 0 to 1 of x squared plus x minus 1 dx. So we're going to integrate this. And we get 1/3 x cubed plus 1/2 x squared minus x, evaluated from 0 to 1. And so when we plug in, we get 1/3 times 1 cubed plus 1/2 times 1 squared minus 1. part, we know that this will be 0 at 0. Ready? Okay, so when we evaluate this, we'll get f1 is equal to 2 plus 1/3 plus 1/2 minus 1. And I'm going to put this in a common denominator, so it's going to be 2/6 plus 3/6 minus 6/6. So this is going to be negative 1/6. And so this 2 we're going to convert to sixths, and we're going to get 12/6. And this comes out to be 11/6. So the f of 1 is equal to 11/6.
And you're given a calculator for most of these problems, so you wouldn't have to worry about denominators.
Yeah, tell me when you're ready. Okay, so now we're going to find the f of 4. We're going to use the same setup that we used to find the f of 1. So we're going to do the f of 0 plus the integral from 0 to 4 of x squared plus x minus 1 dx. So the f of 4 equals the f of 0, which is 2, plus this integral. When we integrate, it's going to be the same thing we found over there. 1/3 x cubed plus 1/2 x squared minus x, evaluated from 0 to 4. So we're going to plug in 4 here. So that's 1/3 4 cubed plus 1/2 4 squared minus 4. Okay, so 4 cubed is
32.
okay, 32 over 3 plus 16 over 2 minus 4. And then and then again at 0, it's just 0 because every part in this equation has an x in it. So this, when you plug in 0, it comes out as 0. So we're going to evaluate. I'm going to do this piece first and then do this. And we're going to convert everything into thirds. So that'd be 6/3 and then plus 12/3. So that's 18. That's 50 over 3. So we know that the f of 4 equals 50 over 3. And from the values we have found, when we go back over here, we were told to find the absolute maximum. And so we state that f of x has an absolute maximum of, and so we look and we try to see which one's the greatest value. And here, it's going to be, it's the same as 25 over 2, and 25 over 2 is greater than 2. So we're going to say, and it was also greater than 11 over 6, so we're going to say a maximum of 25 over 2 when x equals 4, and then we're going to have to justify. So to justify this, we're going to say by candidate's test. And remember, when you see a closed interval, always, always, always use candidate's test.
The second has to do with a graph, a geometric graph of f prime of x with an initial value which is given, and you're asked to find a value or extrema. Okay, so for our third example, we're given a graph of f prime of x, and we're given that f of 2 is 7, and we want to find the f of 4. So what we're going to do is we're going to say the f of 4 equals, and we're going to use net change, of course, the f of 2 plus the integral from 2 to 4 of f prime of x dx. And then we're going to look over here, and right here to right here is our interval. So what we're going to do is find the area, the accumulated area of the graph. So you would use area of a semicircle, which would be 1/2 pi r squared. And our radius right here is 1, so it would just be 1/2 pi. And because it's under the x-axis, it's going to be negative. So it would be negative. So what you're going to do is put 7, the f of 4 equals 7 plus negative pi over 2. And on the AP exam, you don't have to worry about simplifying it any further than that. And then you're done. The final one is particle motion, which is mostly given with velocity or acceleration. You are asked to find position or velocity at a time, depending on what you're given. You may also be asked to find concavity of a position or velocity.
Okay, so by looking at the equation v of t, we find out that v of t is less than 0 on the interval 0 to 3. And so we're going to consider the points 0 and 3. So we're going to find both values at 0 and 3 using net change. So we set it up as x of 3 equals -2, or the x is 0 plus the interval from 0 to 3 of velocity. And we are given that the x is 0 is -2, and that this interval is -8, so we do -8, and we get out -10. So the x of 3 is -10. So now we're going to find since it's negative here, and also on the interval 5 to 6, we're going to look at this endpoint to find where it is furthest left. So we're going to do the x of 6, and this is the x of 0 again, plus the interval from 0 to 6 of v of t dt. And we know that this, by looking at our graph and the information given, is going to be -8 plus 3 minus 2. And this comes out as -9. And since this is the most negative value, we know that the particle is furthest left at t equals 3. So we state this. Where the x of 3, position at time 3, equals -10.
And that's the end. Thank you for watching, and I hope this helps with surviving calculus.
Oh, it's a video.